Have you ever wondered why some materials are hard and some are soft, or why metals conduct electricity? Well, you're about to find out. Today we're embarking on an exciting journey to explore the properties of materials. From hardness to malleability, ductility to absorbency, each property gives a material its unique character. We'll even delve into the world of metals, nonmetals, and some extraordinary materials like graphene. So, buckle up as we dive into the fascinating world of materials and their properties. First off, let's get to know what physical properties are. Physical properties are the characteristics of matter that can be observed or measured without changing the substance's identity. Fascinating, isn't it? Take hardness, for instance. It's a measure of how resistant a material is to being scratched or dented. Think about a diamond, the hardest known natural material. It can scratch almost anything else but can't be scratched by many materials itself. Then we have malleability and ductility. A malleable material can be hammered or rolled into thin sheets. Imagine gold leaf, so thin and yet still gold. Ductile materials, on the other hand, can be drawn out into thin wires. Picture a copper wire used in so many electrical appliances. Now, let's consider absorbency. An absorbent material can soak up fluids. Think about a sponge soaking up water in a jiffy. It's all about the material's ability to hold liquids within its pores. And what about elasticity? It's all about a material's ability to return to its original shape after being stretched or compressed. Picture a rubber band, stretching and then snapping back to its original shape. Each of these properties, from hardness to elasticity, influences how we use different materials in our everyday lives. From the coins in your pocket to the elastic in your hair tie, the physical properties of matter shape the world around us. Isn't it amazing how each material has its unique physical properties? Now think about the various objects around you. Some are metals, some are not. Ever wondered why? Let's dive into the fascinating world of metals and nonmetals. These substances are everywhere, from the phone in your hand to the air you breathe. But what sets them apart? Metals, for starters, are quite the celebrities when it comes to conducting heat and electricity. Ever noticed how a metal spoon heats up when you leave it in a hot soup? That's because metals are excellent conductors of heat. And the wires in your house? They're typically made of metal because metals are also great at conducting electricity. But metals aren't just good conductors. They also have this unique ability to be hammered into thin sheets or drawn into thin wires without breaking. In scientific terms, we call this malleability and ductility. Think about gold, for example. It's so malleable and ductile that it can be beaten into incredibly thin sheets or drawn into superfine wires. Now let's talk about nonmetals. Nonmetals are quite the opposite of metals in many ways. They are usually not good conductors of heat and electricity. So if you've ever wondered why your plastic spoon doesn't heat up in your hot soup, that's why. Non-metals are also less malleable and ductile than metals. If you tried to stretch a piece of plastic into a thin wire, it would probably break, but don't underestimate non-metals. They have their own set of superpowers. For instance, many non-metals are great at resisting heat and corrosion, making them perfect for things like space shuttles and cookware. So metals and non-metals are quite different, but both are incredibly important. They each have unique properties that make them useful for different applications. Next time you see a metal or non-metal object, you'll know why it behaves the way it does. Now let's talk about two very interesting materials, chlorine and graphene. Chlorine, a greenish-yellow gas, is one of the most widely used chemical elements on planet Earth. You may know it from its primary use in purifying water. Yes, the same water you drink, swim in, and use to water your plants. It's chlorine that helps keep it safe and clean. Chlorine also plays a significant role in the production of many products we use daily, like paper, textiles, medicines, and even the plastic in your favorite toys. But what makes chlorine so useful? Its highly reactive nature. Chlorine can easily combine with almost all other elements, creating compounds with a wide range of properties. This ability to form various compounds is what makes chlorine one of the most versatile elements in the periodic table. Now let's turn our attention to graphene. Unlike chlorine, graphene is a relatively new kid on the block. It was invented just a few decades ago in 2004. But don't let its young age fool you. It's already making waves in the scientific community. Graphene is a single layer of carbon atoms arranged in a flat honeycomb lattice. Despite its simplicity, it's one of the strongest materials known to man. It's harder than diamond and more than 100 times stronger than steel. But it's not just about strength. Graphene is also a fantastic conductor of heat and electricity, and it's nearly transparent. The potential applications of graphene are mind-boggling. We're talking about everything from super-fast electronics and ultra-efficient solar panels to revolutionary medical treatments and water purification systems. From cleaning our water to making super-strong materials, isn't it incredible what these materials can do? Ever wondered why you can see through some materials and not others? Or why some materials heat up faster than others? Well, this all comes down to two things: transparency and conductivity. Let's start with transparency. Transparency is all about how much light can pass through a material. Some materials, like glass or water, are transparent. This means that they allow nearly all light to pass through them, which is why we can see through them so clearly. Other materials, like frosted glass or wax paper, are translucent. They allow some light to pass through, but scatter the rest, causing objects behind them to appear blurry. Then there are opaque materials like wood or metal, which do not let any light pass through them at all. Now, let's talk about conductivity. Conductivity is a measure of how well a material can transfer heat or electricity. Materials that are good conductors, such as metals like copper or silver, allow heat and electricity to pass through them easily. That's why metal pans heat up quickly on the stove, and why electrical wires are often made of metal. On the other hand, materials that are poor conductors or insulators like rubber or glass do not allow heat or electricity to pass through them easily. This is why rubber gloves are used when working with electricity, and why a glass window doesn't heat up as much as a metal pan in the sun. So, transparency and conductivity are key properties that determine how we use different materials. They help us choose the right materials for the right jobs, from building windows to designing electrical appliances. Remember, the next time you use a window or an electrical appliance, the properties of the materials make it all possible. Now that we know about all these properties, how do we choose the right material for a task? Well, the secret is in the properties. Each material, whether it's a metal, a non-metal, or something else entirely, has its own unique set of characteristics. These properties determine where and how we can use these materials. Let's dip into a few examples to clarify this. Take metals, for instance. Metals like copper and aluminum are great conductors of electricity. That's why they're used in electrical wires that power our homes, gadgets, and the world around us. Their ability to conduct electricity efficiently makes them the perfect choice for this job. Now let's talk about the superheroes of flexibility: rubber and plastic. Both of these materials are highly flexible and durable, making them ideal for items that need to bend or stretch. Think about rubber bands, plastic bags, or even your favorite flexible water bottle. What about materials that need to withstand high temperatures? This is where ceramics come into play. Their high melting point and heat resistance make them perfect for things like pottery, tiles, and even spaceship parts. Then there's the world of transparent materials. Glass, for example, allows light to pass through it, making it perfect for windows and eyeglasses. On the other hand, materials like wood and metal are opaque, meaning they don't let light through, making them excellent for creating privacy or blocking out light. Lastly, let's think about materials that soak up liquids. The absorbent properties of materials like cotton and sponge make them ideal for towels and cleaning supplies. So, you see, understanding the properties of materials helps us make the best decisions when choosing which material to use for a particular task. In essence, the science of materials is all around us, from the clothes we wear to the homes we live in and even the gadgets we use every day. So, the next time you're choosing a material, think about its properties. It'll help you make the best choice. We've covered a lot today, haven't we? From the physical properties of matter to the unique characteristics of metals and non-metals. We've dived into the uses of chlorine and the invention of graphene. We've explored hard and soft materials, malleability, ductility, and the world of absorbent, waterproof, and transparent materials. We've learned about electrical and heat conductors, insulators, and how to choose the right material for the right purpose. Remember, materials are all around us, and their properties shape our world. Keep exploring, and you'll discover something new every day.